Hello student, I am Dr. Ajay Kumar Sinha. Today I am going to discuss modern periodic law and the present form of the periodic table. Yesterday I discussed Mendeleev periodic table. Today I am going to discuss modern periodic law and the present form of the periodic table. Mendeleev table and this modern periodic table, what is the difference? This you should understand. What is the difference between two periodic law? Question is asked also. Then what is the difference? I am telling. I told you that in Mendeleev periodic table, modification was done. And what was the modification? Then in the place of atomic weight, Mendeleev considered atomic weight. But this in modern periodic law, atomic number is considered. In the place of atomic weight, atomic number has been considered. And who have modified? Then chemist name is Henry Moseley. Henry Moseley, just he modified the this Mendeleev's periodic law was modified by Henry Moseley. And then what is the periodic law? Modern periodic law. Then now modern periodic law became, just I am telling the periodic law, the physical and chemical properties of the elements are periodic function of their atomic numbers. This is the main difference between Mendeleev and modern periodic table. This is the main difference. Now again question arises, why atomic number has been considered in modern periodic table? Then actually what happened, that a plot of under root frequency versus atomic number. One plot was that this under root frequency, nu is the frequency of X-rays versus atomic number was drawn. Then it has given a straight line and not the, you can say, this plot of frequency versus atomic mass or atomic weight. It has not given a straight line. In case of Mendeleev, he has considered atomic weight, then under root nu means frequency versus atomic mass not given a straight line. But here in case of modern periodic law, under root frequency versus atomic number has given a straight line. Correct? Then what he concluded? By this straight line, what conclusion was drawn? Then he means Moseley has given final touch for modern periodic law. Henry Moseley. Then Henry, according to him, what he observed, by seeing the graph, he thereby showed that the atomic number, means Moseley showed that the atomic number is a more fundamental property of an element than its mass number. Again I am telling you, the Moseley showed that the atomic number is a more fundamental properties of an element than its atomic mass. Mendeleev's periodic law was therefore accordingly modified. Mendeleev's periodic law, then it was modified, and now after the modification it was called modern periodic law, and can be stated as the physical and chemical properties of the elements are periodic function of their atomic numbers. This I have told you. Now another important thing, actually I am trying to highlight only important questions, and then answer I am giving you. That question are generally asked in all competitive examination. Then question and answer I will try to give. Okay. Then now another important point I want to tell you, that from the pitch blend, pitch blend is an ore of uranium. Keep in mind, this question is also important. Pitch blend is an ore of uranium. Then from the pitch blend, neptunium and plutonium was found. Listen carefully, question is asked. From the pitch blend, neptunium and plutonium were found, and what are the other two elements which was found along with neptunium and plutonium from pitch blend? Then keep in mind, actinium and protactinium. Actinium and protactinium are also found in pitch blend, total 4. Okay. Direct I am that question I am telling you which is asked. Then along with neptunium and plutonium which were found from pitch blend, actinium and protactinium were also found. Now after that, what is these things? Other important point, that the atomic number is, that I have already discussed. Already I have discussed in the beginning. Atomic number is equal to nuclear charge. Nuclear charge means number of protons or the number of electrons in a neutral atom. That is called atomic number. Atomic number is a nuclear charge. That is, nuclear charge means number of protons, and number of protons is equal to the number of electrons in a neutral atom. This is also important things I have told you. Now next things, again important things, that how this quantum numbers and electronic configurations are related. This is again very important question. How quantum numbers and electronic configurations are related. This is very, very important question. Now listen, that periodic law is essentially the consequence of the periodic variation in electronic configuration, which indeed determine the physical and chemical properties of elements and their compounds. Now it is very clear that due to the electronic configuration, by electronic configuration you will come to know, the physical and chemical properties of the element and its compound, and this quantum numbers are related to electronic configuration. How then this principal quantum number, that is the orbit number. Then here in periodic table you will see many orbit. According to the atomic number you will find many this orbit. Then principal quantum number, that is the number of orbit, correct? After that, while filling this electrons, already I told it start from filling from the lower energy level to higher energy level, then lower energy level to higher energy level, that is the energy level. In energy level, that is the orbit or shell, what you are telling, in that orbitals will be there, then see energy level, but within the energy level orbitals will be there, then orbitals will tell about the quantum numbers. Either it will tell L, azimuthal quantum number, what type of orbitals are there, then that is the, you can say, L value. And after that also you will find that these things, how many you can say orbitals are you are using in filling the electron. Then how many, it means it is telling about these things, magnetic quantum number. I told you that 2L plus 1 minus 2 plus via 0. Then in some orbital like S, only you can say one orbital is there, S orbital, correct? Then maximum 2 electron can be accommodated. If P is there, then Px, Py, Pz means electron will begin to fill first Px, then Py, then Pz. It means you are knowing about the M, magnetic quantum number. If suppose D is there, then dxy, dyz, dzx, dx square minus y square, dz square. Then 5 d orbitals are there. Then now if you are filling the electron, then first you will fill with 1s, then you will go to the second orbit. In that 2s and 2p will be there. 2s and 2p. Then 2s 2 electron, 2p 3 px, p, pz. After that, if it is filled, they will go for the d orbitals. There are 5 orbitals: dxy, dyz, dzx, dx square minus y square, dz square. Then these are the m. Then you have seen quantum number n, quantum number L, quantum number m, while filling the electrons. And means during the electronic configuration. In electronic configuration, all 3 are used. Now fourth one, spin quantum number. Then there is a rule. You first half will be filled. One electron it will be filled according to the Hund rule. Later on I will tell you. First one electron will be filled. Suppose Px, P, Pz is there. Their capacity, you know that their p orbital has 6 capacity. 6 electron can be accommodated. Then first it will start filling 1 electron will go in Px, the second will go in Py, third will go in Pz. If 4 electrons are there, then again it will start filling Px. Suppose 5 is there, then it will go, fifth will go Pz. 6 is there, then we will go to the Pz, like that way. If only 3 electrons are there in p orbital, then one each. Then see, now it is you are observing here 1 each means you are talking about the spin quantum number, Hence, this electronic configuration will tell about the quantum numbers. Very, very important things I told you, and this concept you will use in solving many, you can say, numericals and questions in examination. Now next important things I am telling you, That I am asking first question, after that answer. What is a long form of the periodic table? This question is asked. What is the long form of the periodic table? Now I am telling you. A modern version of the so-called long form of periodic table of the elements is the most convenient and widely used. Okay, this periodic table is most convenient and widely used. Then this periodic table, modern periodic table actually, that's the long form of the periodic table. A modern version of the, actually so many periodic tables they form, but this is the modern. A modern version of the so-called long form of the periodic table of the elements is the most convenient and widely used. And here this periodic table is divided into, you can say, mainly in S, P, D and F block. It is divided into 4 blocks: S block, P block, D block and F block. This is the characteristics of long form of periodic table. Now another things, what is another question, what is the difference between series and periods? Series and periods, what is the difference? Then the term series was used by Mendeleev. The term series was used in Mendeleev periodic table, but in modern it is called periods. Okay, this is the, you should understand. Series means it was used in Mendeleev. Mendeleev used series, but here in modern periodic table it is called period. This is the difference. Now I am telling you further. The horizontal row which Mendeleev called series, here in modern or in a long form it is called periods. Horizontal row, keep in mind, horizontal row, and the vertical columns are called group. In periodic table you will see, I have already attached last class, horizontal row is called periods and vertical are called group. Okay, and elements having similar outer electronic configuration in their atoms are arranged in vertical column, that is in group. What is the difference between period and group? Then period is horizontal row, and group is also called these things family, and it is a vertical. In periodic table it is the verticals. Elements having similar outer electronic configuration in their atoms are arranged in vertical columns, and it is called as a group or families. Example, if you see the periodic table, then you will come to know that, as for example, group 1, then in group 1 only s orbital will be there. In group 1 s orbital will be there, okay, from top to bottom, but size will increase, element will increase, element will be different, but in the last orbit only S1 will come, because in first group, in the last orbit only one electron will be there in s orbital. Then orbit number will increase in group 1, actually group, in the beginning it will be only one group and one means S1. Other maybe further it will increase, maybe 2 orbit, maybe 3 orbit, maybe 4 orbit, maybe 5 orbit. But end will be, in the end, every last means outermost electron always will be in S1. Then see, this is the common. Like that way, in someone maybe S2, then this will increase. Orbit number may increase, but end will be last orbit, 2 electron will be there in each. That is called group 2. Like that way, group 3, group 4, group 5, group 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. Then this I am telling you that every group that this and the last orbit, only this number of orbit will increase, but this will be there. Subcell in that their number of electron only will differ. Similarities will be there in all group. Now I have told about the group or families. According to the now this thing, another question is there. What is IUPAC? What is the full form of IUPAC? Then full form of IUPAC is there, that International Union of Pure and Applied Chemistry. IUPAC. I means international, U means union of, P means pure and applied chemistry. C, IUPAC, International Union of Pure and Applied Chemistry. This is also in some examination full form they are asking. Now I am talking about what is the recommendation of IUPAC. Actually in 1984 he has given a special recommendation. What was that recommendation? That question is asked. Then actually in the old periodic table was in old, it was classified as 1A, 2A, 3A, 4A, 5A, 6A, 7A and 8. Like that way a division was there, starting from 1A to 8A, 7A, and last was 8th group. And one more was there, that is the B, 1B, 2B, 3B, 4B, 5B, 6B, 7B, and last was the 8. 7B, and last was 8. What we are telling? Zero group. That time we were calling zero group. Then this was actually confusing. That's why IUPAC in 1984 he has given recommendation that now directly you write 1 to 18, not A and B, not group that I told you na, 1A, 1B, 1A, 2A, 3A, 4A, 4A, 5A, 6A, 7A, and 8, that is the zero group. And then in B was there, it was like same way, 1B, 2B, 3B, 4B, 5B, 6B, 7B, and 8 was considered as a zero group. Then now recommendation they have given. IUPAC, what it will tell? All world will follow IUPAC rule and regulation. Almost all countries, some exception is there. Then now actually according to the IUPAC, he told no, directly you write group 1 to group 18. What we were telling? Zero group. Now it is called 18 group, 1 to 18 group. This is the recommendation of IUPAC in 1984 he has recommended regarding periodic table. Now again things I want to tell you. How many periods are there? Question is asked. How many periods are there in a periodic table? This is an important question. Then there are altogether 7 periods. 7. Okay. The periods number correspond to the period number. I am talking about the period number correspond to the highest principal quantum number. I already told. The period number, period 1, period 2, period 3, there like that way 7 periods are there. The period number correspond to the highest principal quantum number, n, small n, of the elements in the period. Period tells about the quantum number, principal quantum number, that is the n. N may be 1. If period 1, we are talking about the period 1, then n is equal to 1. If we are talking about the period 2, then n is equal to 2. Period 3, n is equal to 3. Period 4 means n is equal to 4. Period 5 means n is equal to 5. Principal quantum number 5, like that way. 6 also same way, n is equal to 6. This I have told about the period. Now the first period contains only 2 elements. Now again I am talking about the next these things, that in first period how many elements are present. Whatever I am asking now question, I am answering also. These are the very important things. Question is asked in every examination. Then in the first orbit contains 2 elements. Now the second orbit contains, second and third contains 8 elements. Means second orbit contains 8 elements, third also contains 8 elements. And 4 and 5 contains 18 elements, and 6 contains 32 elements. Just to keep in mind, very important things I am telling you. First period contains 2 elements, second and third contains 8 elements, and fourth and fifth contains 18, and sixth contains 32 elements. Then what about the seventh? This is again tricky question. The 7th period is incomplete, not completed, and like the 6th period would have a theoretical maximum on the basis of quantum number of 32. Actually 6th we are writing that 6th period have 32, but this is somewhat theoretical maximum on the basis of quantum number it is written. Actually what happens that in 6th that 14 elements that is you can tell from up to 57 56th periodic table, it start with 55, then 55 is there, 56 is there, 57 is there, and after that directly 72 is there. Then in the middle 58 to 71 is not there, 51 to 72 is not there, but theoretically on the basis of quantum number it is calculated that it will be 32. Then what happened to this 14? Then 14 elements they have written separately, and this is actually known as lanthanide series. Lanthanide series. Same things with 7th, which is incomplete. Many you can say elements are not found. Then, but gap is there, that if it will be found, then they will have this position, that is fixed, but it is undiscovered. Then here also in 7th also there from 89 to, it starts from 87. 7th period starts with 87, 88, 89. After that directly next is 104. Then what happened to 90 to 103? 14 elements. Then again it is kept separately. In the bottom of periodic table, this is written, and these 14 elements are called actinide series. Actinide series. Correct? This I have told you about the lanthanide and actinide series. Again I will come separately. A special focus I will give. Then now I have discussed these things about the periods. In this form of the periodic table, means long form of the periodic table, 14 elements of both 6th and 7th periods, that is the lanthanides and actinides respectively, are placed in a separate panels at the bottom. Okay, this I have told about the two series. And now I have told these things about this main things of the main characteristics and some questions based on modern periodic table I have discussed. Next class again I will discuss next topic, that is also very, very important, and generally I can tell 90% students don't know, more than 90% don't know. That things I will discuss next class, that is the nomenclature of elements with atomic number greater than 100. Ordinary they know, but greater than 100 is very, very less number of students, only very serious student they know. Then tomorrow I will discuss these things. Thank you.